Chapter 14, Exercise 2, Part B, is giving you the name of an ether and it wants you to draw it. And what's a little different about this one is they're giving you what's called the common name of the ether. So you have IUPAC names, and then you have common names. And IUPAC, that's that International Union of Pure and Applied Chemistry. They came up with rules like we've been using on that table. They're systematic, but the organic chemistry had developed before they came up with those rules, and people used names to refer to the stuff they were working on. Those names are called common names. And so far, in naming ethers, we've been going with the IUPAC names. There is, however, a way of naming ethers that's a little different. It's the common name way. And it can kind of only be used for small ethers. So this would be it's a completely correct way to name an ether. It just doesn't work for more complicated ethers, and so it may not be tested all the time. But because it works for small ethers, whenever you run into small ethers, you'll sometimes see this naming scheme, so it's good to have been exposed to it. In this naming scheme, the backbone is not the longer carbon chain. The backbone is an oxygen. The oxygen of the ether is the backbone. So you see that ether at the end, and that's the backbone. And everything else is named as a branch. You can see that it has those YLs there to represent that they're branches. They're branches off of the oxygen. So for this first one, we have a cyclopropyl branch. Now prop means we have 3 carbons. And cyclo means they're going in a ring. A 3-carbon ring, that looks like a triangle. Let me do that. So that's a cyclopropyl group, and that's it branching off of that oxygen backbone. The other one is an isopropyl branch. Now, isopropyl is, again, another common name. That's not an IUPAC name. And these common names for some weird branches you would have been exposed to in Organic Chemistry 1. And I've put them here, so if you want to pause the video, take a look at them, write them down, or study them, you have access to them. The two that will be really important that'll come back a lot are isopropyl and tert-butyl. Especially the tert-butyl. Tert-butyl is very crowded. There's a lot of methyl groups right next to each other, and so it is used to make a point about crowding. Whenever crowding, the $10 term for that is steric hindrance. Whenever that, or crowding, is important, they'll use a tert-butyl group, and so it comes back a lot. And the isopropyl group is also pretty common. So that's what they have here, and really it's just 3 carbons that fork. And so that's our other branch. So we have our cyclopropyl branch, our isopropyl branch, and then the ether oxygen backbone. Oops. And so that is this whole molecule. So like I said, these common names really are only possible when you have a pretty small and simple ether. So that's not the tricky part about this. The tricky part about this is because it was developed before a systematic scheme of naming, there's more memorization involved. There's like, how do you know what isopropyl is? Well, you just memorized it when you were first exposed to it. And so likewise, knowing that this ether here in the name means that oxygen's the backbone. It's something you just memorize. It's because it was developed for historical reasons and kept just because old habits die hard, so it's used as these common names.